Okay, welcome to your first lesson of Unit 8. Unit 8 is going to be all about quadratic functions. So what we're going to start with here is just try to kind of compare these to different types of functions that we've already seen before. So in this do now for today, it's asking us to graph both of the following simultaneously. That means at the same time in your calculator. So just to be clear here, this first equation right here, y equals 2 to the x, this is called an exponential equation. I apologize for my handwriting. I'm still getting used to this because this is exponential because the x is up in the exponent. Now this second function right here, x squared, this is going to be new. We've never really graphed this before, but that's what quadratic unit is going to be all about. So for this, I'd like you to graph. Again, I gave you guys on Google Classroom lots of ways that you can graph. I'm going to be using the Desmos website, which again you can get to just by Googling Desmos graphing calculator. And again, this is asking us to graph two functions at the same time. The first is y equals 2 raised to the x power. So that function looks like this. We graph these a bunch in Unit 5. We know they're kind of these really fast growing curves that get really close to the x-axis. And the second graph, this one is new that we're going to graph, is y equals x squared. So that's this one in the bluish purple right here. So this we've never seen before. So to compare these two together, y equals 2 to the x, our first one in green here, you can see a little more if we kind of zoom out. Looks like a smooth curve, whereas y equals x squared is more of a U shape, which we've never seen before. So again, going back to our lesson, we'll see that these new types of functions we're going to be dealing with are all going to be these U-shaped curves. So our learning target for this first lesson says, I can identify quadratic functions by examining its graph or comparing to the standard form of a quadratic equation. So we're really looking for two things today. We're looking at graphs and we're looking at equations, and we're trying to decide, are they quadratic or are they not? So for this lesson, you're going to need the new packet. The title of this packet is Solving Quadratic Equations Part 1. We're going to get into solving quadratics next week, but for now, our first goal is just to kind of be introduced to what a quadratic equation or function actually is. So for this, you're going to need the first 2 pages of that packet. Again, if you're able to print out the packet, that's great. If not, you can just do your work on a separate piece of paper. So looking at page 1 of our new packet, it says Intro to Quadratic Functions. If a function is quadratic, it can be represented by an equation of the form y equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not 0. This is called the standard form of a quadratic equation. So just like we've had a couple standard forms in the past, we now have a standard form of our new function family, which are quadratic equations. So if you can make any of your equations look like this, it's quadratic. The most important part of this equation is this x squared. We're going to really be focusing on whether or not our equations have an x squared. The second way we'll know something is quadratic, it says if the graph of a function is a parabola or a U-shaped curve. So just like we saw in the do now, our new quadratic equations, when we graph them, will be shaped like a U. For right now, we're just seeing these upward facing U's, but soon we'll get to ones that are facing downwards. So right now, I'd like you to take a moment to read through the 3 problems in example 1. You're trying to determine whether the function is quadratic or not. So go ahead and answer A, B, and C. Read through A, B, and C and try to answer the question in our Think Right Pair Share. It says, what do you notice about the equations of all quadratic functions? So I'd like you to pause this video and take a moment to do that. Okay, so what you should have noticed from reading through this example is that both B and C were quadratic functions. The key feature of both of these is they both had an x squared as their highest power of x. So for what do we notice about all quadratic functions, I'm going to say that they all have an x squared. That is not something that we noticed in A. If you notice, A was just y equals negative 2x plus 20. This was actually in the form y equals mx plus b, which if you remember back from Unit 4 is actually a linear equation. So in this case, what we notice about quadratic functions is that they have an x squared. Moving a little bit further down the page, I just further clarify for you here the three types of function families that we now know about. The first is linear. These ones we learned about in Unit 4. We spent a whole month or so working on this. Linear functions can be written in the form y equals mx plus b, and these are when our x variable has an exponent just with that invisible 1. So those are our linear functions. Then in Unit 5, we started learning about exponential functions. So for an exponential function, it says these can be written in the form y equals ab to the x plus or minus k. So the key feature here I wrote right underneath that is that the x is appearing as an exponent. So some number raised to the x, like 2 to the x, 3 to the x, that's an exponential function. Now here we get to our new type of function for Unit 8, which is all about quadratics. So this is going to be our new unit. And here, again, we're looking for something that can be written in that standard form we saw at the top of the page. And I also gave you a slightly different version of that standard form. Again, don't worry too much about the a and the k. We'll get to that in our next unit. But if it looks like that, it's quadratic. Again, most important thing is if your x has an exponent of 2. So what I'd like you to do right now is try the guided practice by yourself. It says determine if each of the following equations are linear, exponential, quadratic, or other. Other means it's some other function family that you don't recognize because we have not learned about it yet. So please pause this video and try to answer the 3 guided practice problems and then come back to check your answers. Okay, so looking at these 3 guided practice problems, I'm going to start first with the one in the middle, x plus 2y equals 14x plus 6. This equation right here is going to be linear. The reason why is because I see no exponents at all. There's no x squared, there's no x up in the exponent, and I could rearrange this equation if I wanted to by using inverse operations to make it look like y equals mx plus b. Now the first function and the last function that we see here, these are both going to be quadratic. Now even though they both look slightly different, they are both quadratic functions. Again, the reason why we're able to identify these as quadratic is because of that x squared as the highest power of x. Okay, so at this point, we now know 3 types of functions. The next thing coming up is our checkpoint question. So I'd like you to try to do this problem either on a separate piece of paper or just somewhere on the side of your packet. Your checkpoint question for this lesson says, determine whether each equation is linear, exponential, quadratic, or other. So I'd like you at this point to pause this video. You can take as much time as you need to try to answer A, B, and C, and then we'll come back and check our answers. Okay, so at this point you should have tried all 3 of the checkpoint questions. To go over the answers, for letter A, you should have said that this one is linear. The reason we know this is linear is, again, it is in that exact form y equals mx plus b, and we don't see any exponents or any x squareds. The next 2, B and C, these are both going to be quadratic. The reason why we know it's quadratic, again, is we're looking for that key feature, which is going to be the x squared. So we notice that both B and C have an x squared as their highest power of x, and I could rearrange these both to look like that standard quadratic form. So at this point in the lesson, we've come to our independent practice. I want you to reflect on the checkpoint question that we just did. The directions for independent practice are written under each grouping. If you had none or just one of those questions answered correctly, you're going to start with red. If you only answered 2 of those questions correctly, you're going to start with yellow. And obviously, if you got all 3 correct, I would like you to start with green. All of these questions, again, are coming from the packet that says Solving Quadratic Equations Part 1. You're going to be working on page 2. You will need to be submitting your classwork through Google Classroom to get your participation points for this lesson. What we're looking for this is to see the students that started in red answering at least red and yellow, the students starting in yellow answering at least yellow and green, and the students in green answering at least green and the extension. We want to see that you're kind of starting from one level and moving into the next. If you are able, and I would highly suggest, please try to answer all the problems. It's only one page of practice, and the more practice you can get, the better. So at this point in the lesson, you should be pausing this video, going and trying some of these problems, and then you can come back here to check your work. Okay, so to check our answers for the independent practice, again, you're only coming to this part of the video if you've already tried the problems. Here are the answers for numbers 1 through 4 on page 2. Okay, moving to the bottom of page 2, here are your answers for 5 through 13. Again, just to run through these real quick, we know that these questions in 5, 6, 10, and 12 were quadratic. All of those have x being squared. I know that 6 looked a little different. Even though the x is over here, it is still being squared. We can say that number 8 is linear because it looks like mx plus b, and we can say that 9 and 7 are both exponential because we see that x up as an exponent. The two tricky ones here were number 11 and number 13. These ones we just called other because we don't really know what these are yet. 11 has this x to the third power. We've not learned about that, so we're not sure what function family that is. And 13 had the y being squared. We don't know what y squared is quite yet, so for now we'll just call those other. If you have any questions about any of those independent practice problems and want further clarification, please send us a message. Your last task of this lesson right here for the first lesson of Unit 8 is to do questions 1 and 2 on Exit Ticket 8.1. Again, at this point, you need to go back into your Google Classroom, and I've attached Exit Ticket 8.1. If you are able to download and print it, you can answer the questions right on there. If not, just answer them on a separate piece of paper. And for now, you don't need to turn in your exit ticket. You don't have to actually turn it in until you've answered all of the questions from this exit ticket. As you can see, this exit ticket has 4 questions on it, so you'll not be asked to actually turn it in until you're done with all 4 questions. But for this lesson that we just did, please answer numbers 1 and 2. So again, before you finish up this lesson, please make sure that you've uploaded your classwork, a picture of it from page 2, into Google Classroom to get your participation credit. And obviously, as mentioned before, if you have any questions, please let us know.